branch circuit for a boat lift or hoist located in a marina on the water is required to have a ground fault circuit interrupter, or GFCI breaker. This requirement is based on the National Electrical Code, or NEC, specifically Article 555.11, which covers ground fault circuit interrupter protection for personnel. Article 555.14 addresses the placement of ground fault circuit interrupters, and Article 555.15 pertains to boathouses and piers. NEC Article 555.14 states the ground fault circuit interrupters shall be installed in the panel board or at the source of the branch circuit or circuit supplying certain locations. These locations include firstly, bathrooms, secondly, kitchens, thirdly, garages, including attached and detached garages and carports, fourthly, outdoor receptacles, fifthly, crawl spaces, including attic and underfloor crawl spaces, and sixthly, unfinished basements. While this section doesn't explicitly mention boat lifts, NEC Article 555.15 offers more specific guidance, particularly as it relates to boathouses and piers. This article mandates that all receptacles located within 6 feet of the water's edge must be protected by a GFCI. In this scenario, the boat lift or hoist branch circuit is situated on a floating aluminum dock, which effectively functions as a pier. Furthermore, the receptacle supplying power to the boat lift or hoist is positioned within 6 feet of the water's edge. Consequently, a GFCI breaker is necessary to ensure the safety of personnel. The purpose of a GFCI is to detect ground faults, which occur when current leaks from a circuit to ground. This can happen if someone comes into contact with a live wire or a faulty appliance. When a GFCI detects a ground fault, it quickly shuts off the power to the circuit, preventing electrical shock. The NEC mandates GFCI protection in areas where there is a high risk of electrical shock, such as near water. Marinas and docks are considered wet locations, and therefore require GFCI protection for all receptacles and equipment located near the water. In the case of a boat lift, the GFCI breaker protects anyone who may come into contact with the lift or the boat while it is being operated. This is especially important because boats can be subject to stray voltage, which can create a shock hazard. The GFCI breaker will quickly shut off the power to the boat lift if it detects a ground fault, preventing electrical shock. It is important to note that GFCI breakers are different from standard circuit breakers. Standard circuit breakers are designed to protect against overloads and short circuits, but they do not protect against ground faults. GFCI breakers, on the other hand, are designed to detect ground faults and quickly shut off the power to the circuit. When selecting a GFCI breaker for a boat lift, it is important to choose one that is rated for the appropriate amperage. The amperage rating of the GFCI breaker should be equal to or greater than the amperage rating of the boat lift motor. It is also important to choose a GFCI breaker that is designed for use in wet locations. These breakers are typically enclosed in a weatherproof enclosure to protect them from moisture. In addition to installing a GFCI breaker, it is also important to regularly inspect the boat lift and its electrical wiring for any signs of damage. If any damage is found, it should be repaired immediately by a qualified electrician. By following these safety precautions, you can help to prevent electrical shock and ensure the safe operation of your boat lift. To summarize, the NEC requires GFCI protection for boat lifts in marinas because they are located in wet locations and pose a high risk of electrical shock. Article 555.14 and Article 555.15 specifically address the requirements for GFCI protection in marinas and boathouses. By installing a GFCI breaker and regularly inspecting the boat lift, you can help to prevent electrical shock and ensure the safe operation of your boat lift. GFCI breakers work by monitoring the current flowing into and out of a circuit. In a properly functioning circuit, the current flowing into the circuit should be equal to the current flowing out of the circuit. However, if a ground fault occurs, some of the current will leak to ground, causing an imbalance in the current flow. A GFCI breaker is designed to detect this imbalance and quickly shut off the power to the circuit. The GFCI breaker typically trips when the difference in current flow exceeds 6 mA. This is a very small amount of current, but it is enough to cause a dangerous electrical shock. When a GFCI breaker trips, it is important to determine the cause of the ground fault before resetting the breaker. Common causes of ground faults include damaged wiring, wet equipment, and faulty appliances. If you are unable to determine the cause of the ground fault, you should contact a qualified electrician for assistance. It is also important to test GFCI breakers regularly to ensure that they are functioning properly. Most GFCI breakers have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFCI breaker should trip. If the GFCI breaker does not trip when the test button is pressed, it should be replaced immediately. In addition to GFCI protection, it is also important to ensure that all electrical equipment in the marina is properly grounded. Grounding provides a safe path for current to flow in the event of a ground fault. Proper grounding can help to prevent electrical shock and minimize damage to equipment. The NEC provides detailed requirements for grounding electrical systems. These requirements should be followed carefully to ensure the safety of personnel and equipment. Furthermore, regular inspections of the electrical system in the marina are essential. These inspections should be performed by a qualified electrician and should include a thorough examination of all wiring, equipment, and grounding systems. Any damaged or defective equipment should be repaired or replaced immediately. By following these safety precautions, you can help to prevent electrical accidents and ensure the safe operation of the marina. The presence of aluminum in the floating dock structure does not negate the need for GFCI protection. Aluminum is a conductive material, and if it comes into contact with a live electrical wire, it can become energized, posing a shock hazard. Therefore, GFCI protection is still required to protect personnel from electrical shock. GFCI protection is required for all receptacles and equipment located within 6 feet of the water's edge, regardless of the type of dock construction. The NEC requirements for GFCI protection are based on the potential for electrical shock, not on the type of materials used in the dock construction. Furthermore, it's crucial to understand the difference between equipment grounding and GFCI protection. Equipment grounding aims to provide a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers to trip and clear the fault. This protects equipment from damage and reduces the risk of fire. GFCI protection, on the other hand, is designed to protect people from electrical shock. It detects even small amounts of leakage current to ground and quickly interrupts the circuit, preventing a dangerous shock. While a properly grounded system is essential for electrical safety, it does not provide the same level of protection as a GFCI. A ground fault can still occur even in a properly grounded system, and a GFCI is needed to detect and interrupt the circuit quickly enough to prevent a serious shock. Therefore, both equipment grounding and GFCI protection are important components of a comprehensive electrical safety system in a marine environment. Remember to always consult the latest edition of the National Electrical Code and local electrical codes for specific requirements and regulations in your area. These codes are updated regularly to reflect new technologies and safety practices. Consulting with a qualified electrician is also recommended to ensure that all electrical work is performed safely and in compliance with all applicable codes. In summary, the NEC requires GFCI protection for boat lifts and marinas due to the inherent risks associated with water and electricity. Article 555 provides specific guidance on GFCI protection in these environments, and it is essential to follow these requirements to ensure the safety of personnel and equipment. A GFCI breaker is a crucial safety device that can prevent electrical shock and save lives. Always prioritize safety when working with electricity, and consult with a qualified electrician if you have any questions or concerns.